Well, guess what, guys? Lucky you, Mr. B messed up on the recording, so you get to see two answers done. We'll do this one in a different color. So I'm going to go through B, answer choice B, because when you do these multiple choice questions, you should be going through each one to make sure you're getting rid of the ones that are not correct. So just to explain what I did up here, I underlined the hundredths place, which let me know that I'm dealing with decimals. Then I wrote out my decimals that I remembered from fourth grade, which I have the tenths and the hundredths. Remember, when you see the TH, then you know you're dealing with decimals. So the question is asking which one of these amounts, when filled out on this chart, would have the 8 in the hundredths place. So I added up, I labeled all of the money, the change, and the dollar bills. I added them up, and for the first one I got $7.92, which here is the hundredths place, and I see no 8 there, so that's not correct. So I would do the same thing for choice B, lucky you, as I would label. This is $1. Well, it's not very easy to see. Let's go back to blue. That's $1, $1, $1, $1. So as far as dollar amounts, I see that I have 1, 2, 3, 4. So I'll do this over here on the side. I would put a $4. Then I would label my change. This is 25 cents, which is a quarter. Then I have a nickel, it's 5 cents. Another nickel, that's 5 cents. This is a penny, that's 1 cent. That's another penny, that's 1 cent. And this looks like also the back of a penny and the back of a penny. So I have a total of 25 cents here. I would put that to add there. And then these, I'm just going to put them together because they're pretty easy to go 5, 6, 7, 8, 9. So that's 9 cents. Then I add them together. 5 plus 9 is 14. Regroup. 2 plus 1 is 3. Bring my decimal straight down because I'm adding. And then I have $4.34. Here's the hundredths place. Oh, you can't see that. I'm sorry. Here's the hundredths place that I'm looking at. That is not an 8. So this means B is not correct. Okay. And what I said on the first video that I'll say again because I messed it up is that I'm not going to answer the question for you. I'm going to show you the process on how to solve it, and then it's up to you to go through and check your work and make sure that you follow the same kind of strategy, or at least came up with an answer. Okay. Obviously, if you chose A or B, you know you have to rework the problem because those are incorrect. Okay. Here's number 2. This is a doozy. I'll read through it. It says the fire station crew bought 76 cans of vegetables and 53 cans of soup to stock their pantry. They have 12 shelves in the pantry, and each shelf holds 9 cans. One of the firemen said he thinks they bought more cans than the pantry will hold. He drew the strip diagram below to represent the total number of cans. So what we're looking at here is this number is the total cans. And it helps to label these things because when you come back to work with the numbers should have a name in a word problem. They should be labeled. So that's 129 total cans. Then he drew the strip diagram below to find out if they bought more cans than the pantry will hold. And then he has all these 9s here. And then C, we've got to figure out what C means. Which equation should the fireman use to find the number of cans C the pantry will hold? Okay, so that's what C is. How many cans? Will pantry... I'll put hold over here. Hold. How many cans will the pantry hold? So before I even look at the answer choices, I'm going to figure out that question. How many cans will the pantry hold? So looking back at my word problem, it says that there's 12 shelves in the pantry, and each shelf holds 9 cans. So if I was drawing this in my head, let's go down a little bit, I would say that I have, 12 shelves. I'm not going to go all the way down, but you get the idea. Let's pretend these are shelves. And each of these shelves holds 6, 7, 8, 9 cans. So I can see already that I'm kind of making what you remember from third grade as an array, some kind of math problem here. If I had to add all these together, right, all the way for each shelf, which is 12, there's a better way to do repeated addition, that's multiplication. So I would take the number of shelves, 12 shelves, and I would multiply that by the number that each can hold, which is 9. And that would give me what? If I multiplied 12 shelves times the number of cans that it holds, number of cans held, that's going to give me what? It's going to give me C. How many cans will the pantry hold? Well, this will tell me. If there's 12 shelves and each shelf holds 9 cans, if I multiply those two bad boys together, I'm going to find out how many we can hold. So look at your answer choices and see which one matches what you see here. Good luck. Let's go to number 3. Here's number 3. Let's center this a little bit more. Monroe bought a block of cheddar cheese that is labeled 5 kilograms. He decides to cut the cheese into blocks that have a mass of 200 grams. How many blocks of cheese will he have after he has cut the block? Here's a hint. 1 kilogram equals 1,000 grams. So he bought a block of cheddar that is labeled 5 kilograms. He decides to cut the cheese into blocks that have a mass of 200 grams. How many blocks of cheese will he have after he has cut the block? So I need to change one of these, right? Because actually the answer choices should be labeled as grams or kilograms. But we're dealing with grams because we're cutting them into blocks that have a mass of 200 grams. So that 5 kilograms, we have to change that to grams. And we know that 5 kilograms, we have to change that to grams. And what we have here is the hint. 1 kilogram equals 1,000 grams. Well, that's kind of easy because I know that 1 kilogram equals 1,000 grams. How did I get from 1 kilogram to 1,000 grams? I multiplied by 1,000. So if I multiplied by 1,000 to figure this out, then I could also multiply by 1,000 here, which would give me a certain amount of grams. I'm not going to give you that answer. Now, once I have that, then I've successfully converted this into grams. But now I need to decide how I'm going to take this amount and change it into blocks or sections of 200 grams. So I have to take whatever this is, and I have to divide it into sections that are 200 grams. And maybe that'll help you come up with the answer. Okay, let's go to the next one. This is number 4. Yeah, this should be number 4. Okay. And it looks like Terrence found a product for 9 times 81. 9 multiplied by 81. Her work is shown below. 9 times 81 equals 9 times 80 plus 9 times 1 equals 720 plus 9 equals 729. Okay, I want to give you a really big hint on this one. I want you to take these terms that you have here, especially these 3. So associative, cumulative, and distributive. Let's take those 3 terms. And here's what I want you to do. Don't worry about halving and doubling, okay? Because that's not a property. So I'll throw you a bone and give you that one. But what I do want you to see is that these 3 properties can be found on I want you to go to google.com and I want you to type in these properties and see which one do you think matches what this person did here. Okay? I could write out all the definitions for you, but you have a resource in front of you now that you can do that. So I want you to try it, and if you do have problems with that, just send me a message on Schoology, or next time we meet in class, you can let me know. But I want you to do a little bit of research on your own and see if you can figure those three definitions out and which one matches what they did here. Or maybe you already know. Okay? Next, question number 5. Which figure does not have at least one line of symmetry? So I'll give you a hint on this one. Here's a circle. Symmetry. Symmetry means something like that. And again, you have a resource at your fingertips that you can look up what symmetry means. But I'm giving you a visual. Maybe that will help you come up with which figure does not have at least one line of symmetry. Number 6. The rectangles below are shaded to represent two different fractions. Which comparison represents the shaded part of the rectangles? So you can't see it here, and I'll fill it in for you, but the shaded parts are this one, this one. I'll color in the shaded parts so it'll show up on the video a little bit better. This one. And fractions are a funny thing. Super easy when you get them, super difficult when you don't. So let's take a look at the two fractions that are in these models. I know that the total number of the boxes is going to be my denominator. And I know that denominator goes on the bottom and numerator goes on the top. So I count the shaded sections of this one. I have 1, 2, 3, 4. I'm sorry, I count all of them. The denominator is a total number of boxes. 1, 2, 3, 4, 5, 6, 7, 8. So this is an 8. And over here I have 1, 2, 3, 4. There's my 4. That's my denominator. The total number of boxes is my denominator. The ones that are shaded in, that's my numerator. 1, 2, 3, 4. Over here I have 1, 2, 3. So there you go. What you need to decide is, looking at these symbols, which one compares these the most. Here's a little trick I like to use when I do comparisons. Okay? I use this. And I write the word get. I'm sorry. It's the word leg. Apologies. I lost my mind for a second there. It's leg, L-E-G. This one is less than. I was like, what is get is for something else. I knew that was right. This one is equal to. And this one is greater than. So I had two choices there. One, I could stop the video and start all over. Or two, I can just show you that even I make mistakes. So that's what I write, leg, when I write the symbols. So I know that that symbol means less than. The middle is equal to. And then the symbol aiming to the right is greater than. Leg, L-E-G, leg. Less than, equal to, greater than. So find out which fractions they are, and then you're going to have to decide which fraction is less than, equal to, or greater to the other one. All right? Number 7. Susan has a scarf that is shaped like a rectangle. The length of the scarf is 48 inches. The width of the scarf, the width is half the length. She plans to sew fringe on the widths of the scarf only. How much fringe should Susan buy? If you don't know what this word means, fringe, it's like the little stringy things at the end of a scarf, or sometimes at the end of a blanket, like little squiggly little strings. So I'm just going to do what it tells me to do here. I'm going to follow exactly what it says. She has a scarf that's shaped like a rectangle. Okay. So it's going to be something like this. It's a rectangle. The length of the scarf is 48 inches. 48 inches. That's the length of the scarf. The width is half of the length. So this part here, which maybe this model isn't to scale, but I'm looking for the math concepts, not drawing an accurate model right now. 48, half of the length. So what's 48 in half? Well, I could divide by a number to find the half, right? I could do that. What would that be? So once you figure that out, then that's how the width is right here, this number. But guess what? There's two sides, so there's going to be a side over here too. So this number, that's a question mark, is going to be where she needs to sew the fringes on, the little frilly things like, like that kind of. Yeah. So I know that this 48, and then the width is half of that. So once I figure out what that half is, then that's going to be the width of that side and the width of that side. Because I'm not going to put fringes on one side. I'm going to put it on both sides. And then that will give me my answer. Good luck. Ooh, we're getting towards the end. Here's number 8. Each picture below represents a different amount of money. Which amount of money has a value that is greater than 85 cents and less than $1? Okay, so I would go through and label my money, right? This is a quarter. It was hard to see. Let's put it on top. This is 25 cents. 25 cents. These are dimes. This is a nickel. And I have 3 pennies. So I'm looking for more than 85 cents, but not more than $1. So this would be 20. I know that 2 quarters is 50 cents. And then I could count 20 here. That's 20 cents. 5, 6, 7, 8. 5, 6, 7, 8. That's 8 cents. So that would be 8 cents here. 5, 6, 7. Bring my decimal down because I'm adding, and I have 78 cents. It's not greater than 85. It is less than $1, so it does meet that criteria, but it's not less than 85. I'm sorry, but it's not greater than 85. So that means it's not going to work. It has to be more than 85 cents, but less than $1. So it meets half the criteria. Okay, and just follow that same strategy for the rest of the problem. Here's the last one for today. Yay, we did it. We're going to be less than 20 minutes. That'll be amazing. A hotel is setting up tables and chairs for a banquet. 1 table has 8 chairs. 2 tables have 16 chairs. 3 tables have 24 chairs. And 4 tables have 32 chairs. The input-output table represents the relationship between the number of tables and the number of C chairs. The rule for the relationship is T times 8. How many chairs will 5 tables have? Okay, so it's real easy when they give you the formula, right? This is T times 8. That's the formula. So if that's true, then that means 1 times 8 is 8. 2 times 8 is 16. 3 times 8 is 24. And these are all checking out. 4 times 8 is 32. So I know that the next one is going to be 5 times 8. And that answer is, you got to figure that out yourself. Good luck. Hope that helps. And that's the last page. See you next time.